All right, let's solve this quadratic equation. Now, anytime that we have a quadratic equation, there's a certain hierarchy in terms of the processes that we use to solve this. What's going to be the best thing? What's the easiest? You know, if you're going to do something, you always do it the easiest way, but if that doesn't work, you go to the next easiest, and so on until you have nothing else to do except for the yucky thing that's left, right? So when we're trying to solve this, this is the first thing that we should think, and I'm sure a lot of you guys think this from the outset anyway. WTF. Now, I know that this is going on the internet. So here's WTF does not mean what you think it means. It does not mean Wednesday, Thursday, Friday. It means would that factor. So if I'm looking at a quadratic equation, the first thought is would that factor. Does this guy factor? No matter what you try to do with the 7, it's not going to break down and give you the 3. So this guy does not work. The second thing that I would want to look for is, do I have a problem where I could use the square root property? Is my variable completely contained within a square? Although I do have my variable squared here, this guy throws it off and I can't instantly use the square root property. So the answer, no, don't do that. Then we would jump down and we'd say, what about completing the square? I can always complete the square, but it's not always the best thing to do.
Can you re-explain why we can't use SRP?
The square root property can't be used because I don't have my variable contained entirely inside of a square, because there's this other guy out here. He throws me off. If I didn't have this, oh, square root property of this guy, no problem. But he messes things up. Completing the square, like I was saying, can always be used, but it's not always the most effective thing to do. Now look here, this guy's already a 1x squared, so that part's good. However, the coefficient of x is what? It is 3, but in a more general sense, it's an odd number. And what was that big thing we had to do with completing the square? There was that little jingle. How did that jingle go?
Divide by 2 and square it.
Okay, I think you should have a little more attitude than that, but that's all right. Divide by 2 and square it. Yep. Divide by, see, see, now you made me boring. I feel boring now.
Oh,
but if I divide this by 2, what do I get? Fractions. Oh, the wall's coming to an end. No fractions, please help me. So you don't want that, right? Don't create fractions for yourself. It will be bad. So then as a last resort, I'm going to go to the quadratic formula. I'll abbreviate that as QF. Anytime you see any of these abbreviations on a test or a homework, that's giving you the clue as to what you should have done, because you probably did it the wrong way or a very long way. And please don't even try to take this to the dean, because she already knows what it means.
What is QF?
Quadratic formula.
I wasn't going to say that, but okay.
Now, do we know? Well, we know the quadratic formula, right?
Yes.
There's even a song that goes with it. We just did that.
Yeah, sing it again.
So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order for us to use this formula, you have to accurately identify your a, b, and c. Now, let me go back to the last page that we had here. For the quadratic formula, the quadratic equation was set up like this. You've got your a, b, and c right there. You're just going to pick out those coefficients and the constant to plug into your formula. Are you with me? But notice that it has to be equal to 0, because if it's not, then it doesn't work out. So my equation is equal to 0. Can you tell me what is a, b, and c? What's a? Positive 1. What's b?
Positive 3.
Positive 3, and c equals?
Positive 7.
7. Now notice I'm not bringing any x's. I'm just looking at the coefficients, right?
Jeez.
So when I do my formula and I just plug things in. Now, I'm only going to show you the amount of work that I'm showing you right now for the first time, because this is a lot more than we need to see. This is negative times your b, which is 3, plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which equals 7. And this is all over 2a, so that means 2 times 1. Again, I'm not going to be showing you this much work because there's a lot of stuff that we can just take care of in our heads. For example, I didn't need to write negative parentheses 3. I could have just written what?
-3.
And looking ahead, we know we've got 3 squared. You probably don't need to write 3 squared. You could just write
9.
9. And then minus 4 times 1 times 7 is what?
28.
Positive or negative, though?
Negative.
It's going to be negative. This is so important that you pay attention to your signs. I'm looking at this guy right here. What does he equal? And he equals the negative 28. So pay very close attention. The biggest problem that students have when using the quadratic formula is getting the sign right. And this is all over 2 times 1 is just 2. That's all I need to say. Now, the only other thing that I need to do here is to simplify, and most of your simplification will revolve around your radical. So what do I need to do inside that guy?
-19.
So plus or minus the square root of negative 19 all over 2. Am I done here? Can I just box this guy?
No.
You wish, but we can't. Why not? What's left to be done here to simplify?
You need to do something.
Well, 19, you can't do anything with that. But I've got a negative factor, so this becomes what?
I.
So x is equal to negative 3 plus or minus, the I comes out of this guy, we put that out front, so I square roots of 19, and this is all over. It's all over 2. Now, look at this answer here. Not only is it complex, but it also contains radicals. Were you going to get this from just factoring?
No.
No. And this is some nasty, you-know-what, to have to deal with if you were completing the square. So, quadratic formula can be very nice. But again, it's one of those guys that you want to use as a last resort, because if you can factor, factoring usually happens very quickly. Completing the square, as long as terms line up well, it's pretty easy as well. Quadratic formula, save it as a last resort.